So let's look at the sliding window algorithm to solve the shortest subarray problem reaching up to a given target. Like we discussed, this is going to be a variable size sliding window. The way it will work is we'll maintain two pointers, left and right, and we are obviously interested in every value, the contiguous range of values from left to right. Indeed, that is the essence of sliding window. Remember, the pointers plus the values in between. So that's what we are interested in. Because the metric of interest is the sum of these items. So we're going to find the sum of the items in this window. We'll compare the sum with the target. If we find that the sum is smaller or equal to the target, well, we will move the right pointer outwards. Remember, the two pointers start with being zeros. At the same point, I move the right pointer outwards. In other words, I will expand the window. Now, why does this make sense? Well, because remember, all the numbers are positive, which means that if I were to increase the right pointer, move it outwards, I'm adding one more number to the window, and that means that I'm going to increase the sum of the items in the window. On the other hand, if the sum is larger than the target, well, I will contract the window by moving my left pointer to the right side. Again, remember, because the numbers are positive, when I do this, when I move the left pointer, contract the window, the sum of the window in fact decreases because the leftmost item leaves the window. Now think about it. This is very, very logical. Our goal here is to become equal to the target and the shortest window that does that. So if we find that the given window is smaller, we would want to increase the sum and hence move the right pointer. If we find that the sum is larger, we want to decrease it, and we'll do that by contracting the window. One thing to make the code consistent, to make the code clean, we will always ensure that the left pointer does not go beyond the right pointer. We'll take care of this specifically in the code. And in fact, we'll keep doing this until the right pointer reaches the end of the list. It's actually a little bit more than that, as we'll see later. But broadly, this is the idea that the code will end once the right pointer has reached the end. We'll see this in a bit more detail. Now, these words will become more clear if we can look at an example, and that's exactly what we'll do. So let's look at an illustration here. Let's say I have this list 1, 3, 2, 1, 4, 1, and so on. Target is 8. Remember, I start with my left and right pointer, both pointing to the item 0. So this is the window. Sum is clearly 1. This sum is smaller than the target, which means that I must become larger. And the way I become larger is, look, I move the right pointer outwards. So when I do that, it becomes 1 and 3. This is my window now. The sum is 4, still smaller than the target. So I further open up the window. I expand the window. I see, okay, the sum is now 1 plus 3 plus 2, 6. Still less than the target. So I further increase. I go to 7. I further increase the window, and it turns out that at this point my sum has become 11. Now notice the sum has become more than the target. Hence, it's time for me to contract the window. And the way we contract the window is, remember, by moving the left pointer. So I do that. It turns out my sum is now 10, which is still more than the target. So I go and further contract. It becomes 7. This is now less than the target. So I expand, move the right pointer. Now this sum is 8. So here I found my first window, which is adding up to 8. So if my problem statement was, well, find me the very first contiguous array of whatever length which adds up to 8, I would have stopped the algorithm here because indeed I have found it. However, here the problem statement is that, look, find me the shortest, right? So this is of length 4. Perhaps there are more in there of length 3, length 2, maybe even length 1. Hence, we got to keep searching. Since the sum is 8, which is equal to the target, it's time for us to expand the window, and that's exactly what I do. I add the next item, so the right pointer moves out, the sum now is 11. Time to contract the window because look, 11 is more than 8. I contract the window, I am at 9. I go and further contract the window, and it turns out that, look, again I found my sum 8. So 413. Now clearly this is shorter than the previous window. So we are, obviously we done, probably find the shortest one, but we don't know. We got to search further because there may be even shorter windows, right? So now that the target is equal, I will expand the window. I move the right pointer outwards. This becomes 10. 10 is more than the target. Time for me to contract the window. So this is 6 now. Less than the target, so I expand the window. That becomes 7. Less than the target still, I go and expand the window, and this is 8. So now look here. This is 5 contiguous items adding up to 8, the target. If my goal perhaps was, let's say, to find the longest window that adds up to this target, then maybe this was a solution I was looking for. Or perhaps I could have been also looking for a situation where I wanted to find all the contiguous subarrays which add up to 8. So again, I could be maybe adding, let's say, all the times that I found it. But nonetheless, here the sum is 8. It's time for me to expand the window. I expand my window, the sum becomes 10. Now, this is very, very, very interesting, something to think about. In fact, I have reached the end of the list. But as I told you, there is more to it, because think about it. I still have a window that is to be searched. Perhaps my last item itself is 8. Think about it, the situation. If the last item is 8, and if I were to stop my algorithm right here, I am going to miss this point, right? So I will continue with my rule. My sum is more than 10, more than 8. So I contract the window by moving the left pointer inwards. Sum becomes 9, still more than the target. I contract the window again. Now the sum is 6, which is less than the target. In fact, this is where I'll terminate, because now think about it, there is no way to go, because if I were to go further right with the left pointer, I am only going to reduce the sum, and obviously there's no point in going back because I have already tested this. So again, summarizing the rule here, expand the window by increasing the right pointer if you are equal to the target or below the target. On the other hand, contract the window by increasing the left if we are above the target. And you think about it, so beautiful, so amazing, that we are clearly moving in the right direction. For example, if you think about it, compared to the naive algorithm, we would have, checked every item being equal to 8. We have not done that. We have not tested for every pair either, because we have this very clear rule that, if I am below the target or above the target, I move according to that. Basically, I'm trying to be close to the target. So if I'm going above target, it's time for me to contract. If I'm going below target, it's time for me to expand. Now, this rule is really, really, really amazing. Very clear. This is bringing in efficiency. Think about it. Once you understand the mechanism of this well, the code will become that much more clear, but really, really interesting. At YByte, we always learn programming in a step-by-step manner, going over every detail, because that is when programming becomes really interesting. Do look at our website, www.ybyte.in, for a lot more such content, and forever enjoy coding. Thank you.